All right, MX3 has us looking at matrix equations, rewriting our system. So we're all the way back in like our very first unit on systems of linear equations. So if we want to rewrite our problem as a matrix equation, nearly everyone did this perfectly. We just need to write out the coefficients for our variables in a matrix. Boop. And then we are going to rewrite our variables in a column vector with those variables. And we know the reason we're doing this is because as we looked at this, if we look at this as like a linear transformation, if we look at this as linear combinations, right, we have this, okay, this is going to be 1, negative 1, 0 times my x1 plus x2 times that second vector, right? Plus, and this is not what was asked for. I'm just feeling like, let's see why this works out, because I think for some students there might be that moment of like, well, here they're listed x1, x2, x3. It feels weird to take those and put them into a column vector, but not really at this point in the course. We're hitting this towards the very end, so it seems almost much more natural to do this. Some students, just to cut hand, like very few, were missing that x1, x2, x3 vector. And then we need an equal, right? It's an equation. So again, we had some issues there. And we have our solution vector off to the side. Boom. So basically, I mean, if you think about this as a transformation, a linear transformation, it's like what combination of those vectors do we have to have in order to map to that negative 19, 15, 9 vector. All right, so that was our matrix equation. Second piece asked you to use that to solve our original system of equations. So the idea here is this thing without the little inverse symbol was my A matrix, right? And we just said A times this X vector is equal to our solution vector, right? And so if we can come in here and multiply by our inverse, these will, right, that'll do exactly what it's supposed to do. The multiplication and inverse matrix by the original matrix will give us back out our identity matrix. And then we'll just end up with the vector that we're trying to solve for, our variables, right? One issue here is vector multiplication, not vector, matrix multiplication. Order really matters. I think only one person did not write that A inverse on the correct side of that solution vector, and they got in trouble. But basically, I needed something to show me that you were doing A inverse, this result over here, times that original solution vector to get back out what we are looking for. So original solution vector was negative 19, 15, and 9. Our matrix here, 8, 7, 5, negative 1, 0, negative 2, negative 2, negative 1. If I do all this multiplication, I'm going to get that x1, x2, x3 column vector that we set up. So all you had to do here, all you had to do was do the actual matrix multiplication. I would like to see that. I think some people sort of just left this as an exercise to the reader. And I'd like, yeah, I guess, yes, I could solve it from there. But given that some of us had struggled with the matrix multiplication and ending up in like the right dimensions, I think it's probably good to actually do that here. So this one's not the most kind version because I have to do 8 times the negative 19 plus 7 times 15 minus 5 times 9. Oh, I've done something horribly wrong. Let's verify that I've done the thing right. That's good. And that's all positive. Oh, it's plus. So I know the answer is not this big. Changed it something to a negative. So we have a negative 2. I'm pretty sure the next element was 4, and then I think it was a negative 1. But anyways, it was really what I was hoping for. I didn't need to see all of this beautiful work, though I did love everyone who did that. I appreciated it. But I did want to see this setup and your solution as part of that work. Even better if you did something to show me why indeed multiplying by that inverse matrix is such a clutch move. Now, if you didn't put your inverse matrix on the correct side of that solution vector, yeah, it would have left to a 1 out of 2 because we couldn't have actually evaluated that matrix multiplication.